This is chapter 2.1 on units of measurement. So if you're going to study any science, you're going to do measurements. And then those measurements are going to be used in order to find out what you are looking at. You need to know if something has changed in order to understand what's going on. So you measure things like length, you measure things like weight, you measure things like concentration, how dense something is, or how much stuff is dissolved in something. All of these then have units of measurement that you're going to then use. So you can measure your height, or you can look at a watch and find out what the time is. You can look at a temperature on a thermometer or a mass on a scale. So all of these are different measurements using different instruments. So in the picture here, we're measuring how concentrated something is. So how much stuff is dissolved in the liquid, whether that's water or some other stuff, and then that can be weighed out and measured. And then as it changes, you are looking for trying to understand some kind of a concept behind how things are working based upon the changes in things you can measure. So you need some kind of a tool. If you're going to measure mass, you need some kind of a scale. And you can imagine very, very expensive scales that can measure thousands and thousands of a gram, or very simple scales that you could simply take two oranges and put them one in your left hand and one in your right hand and determine which one is heavier. So it depends on what you need as to what you use. The units of a measurement need to be included in that measurement for it to make sense. So you can't say those oranges are 6 because that doesn't make sense. Are they 6 degrees? Is that a temperature you're measuring? Are they 6 pounds? Is that a weight that you're measuring? Are they 6 inches across? That would be determined. So the units have to be part of a measurement, otherwise they don't make really any sense. SI units. This is from a French word. So SI is System International in French, my French accent. It simply, every person who does some kind of scientific work, if they write a paper for the entire world to then know what they've done, they agree to use certain units. Then those units are understood by everyone that's going to read that paper so that no one is confused. So you don't use inches and pounds everywhere, even though we use inches and pounds here. Most people do not use those. So if you're going to write a paper, you agree to use certain units. It's based in the metric system, and the metric system is in base 10. So everything is 10 times something else. Every unit is 10 times or 100 times or 1,000 times or 1,000,000 times. Something based in 10 that's easy to do the math with. So the SI units and the metric units of measurement are the meter in the metric system, the liter, the gram, the second, and Celsius. Now, I don't measure in grams. I usually measure in pounds because I live in the United States. There's 192 countries in the world. 3 countries use the British system. It's called the imperial system or the empire system. Britain, which started it, doesn't even use it. All the other countries use the metric system. So you would think in grams or you'd think in liters. Now, we do liters. I don't know why that's the only company in America that does it. Pop is normally sold in 2-liter bottles. But everything else was still in inches and miles and feet, etc. Celsius is a scale for heat based upon water. So water freezes at a certain heat, and it boils at a certain heat. So they simply took the freezing point of water and called that 0. They took the boiling point of water, called it 100, and then divided that difference between 100. And 1/100th of that space, or that difference, is called a degree Celsius. It used to be called centigrade because it was based on 100 degrees of difference between water freezing and water boiling. The SI unit for heat is Kelvin, which is simply the Celsius degree taken all the way down to the lowest possible temperature that exists when molecules don't have any energy at all. So essentially it's a variation of the Celsius scale. So SI units for volume is not using liters. They use the cubic meter. So a box with a meter measured on each, length, width, and height, and then the volume being that inside of that box. Kilogram instead of gram because it's a little bit bigger, and then everything else is the same. So let's do some simple review. You may actually know this. The meter is the measure of length. In fact, the word meter means to measure. That's where the word comes from. So it's a measurement of length, how long something is. So a meter stick is a little bit bigger than a yardstick, just a couple inches bigger. So the only thing I ever have students memorize is there's 2.54 centimeters in every inch. So in the same amount of space that 1 inch occupies, 2.54 centimeters occupy by definition. And so you can exchange metric system into imperial system by the centimeter. A volume also can be converted. But really, I would simply use the centimeter. I only have people learn the centimeter. 1 centimeter, 1 inch is 2.54 centimeters. So a liter is 1,000 milliliters. Okay, and a milliliter, by definition, is the volume inside a box that's 1 centimeter by 1 centimeter by 1 centimeter. So the measurement of that cube is centimeter, centimeter, centimeter. So 1 cubic centimeter is a milliliter. So if I know how many inches that box is, then I can change that to centimeters with 2.54 centimeters to the inch, then know what a milliliter is, and then there's 1,000 milliliters in a liter. So you can convert one to another. And then the cubic meter is the SI unit. For mass, you have the gram. And the SI unit's the kilogram, so 1,000 of these grams. That's a piece of metal somewhere in a museum. That used to be the reference, a reference of that. So it's a certain amount of weight. Temperature uses Celsius, like I explained, and Kelvin in the SI unit is simply the Celsius scale going all the way down past 0 Celsius, down to the point where there's no energy at all, where there's no vibrations in any material. Time uses the second, okay, always. So let's do a couple examples. For each of the following, indicate the unit describes length, mass, or volume. A bag of onions has a mass. That's obviously mass. A person's 2 meters tall. If tall is measuring a single dimension of length. So that's how high he is. Medication contains a 0.5 gram of aspirin. That's a mass. So a gram is a mass. A bottle contains 1.5 liters of water. That's a volume. Which of these are SI units? This is a little bit confusing because even if you know the metric system, there is modifications in the metric system to do these units if you're going to write a paper. So John's height is either in yards, feet, or meters. Which one is SI? Meters are SI. The race was won in seconds, minutes, or hours. You think that's no big deal, it's just time, but if you're going to write a paper, it's actually going to be in seconds. Seconds is the SI unit of time. The mass of the limit is ounces, kilograms, or pounds. It would be in kilograms. And the temperature is going to be in Kelvin. Kelvin is the accepted value if you're going to write a paper. So, nice, easy lesson. I hope you got it really fast.